Yo, what is up, guys? Welcome back. Another day, some more problems. I think this is day 178. Crazy. It's crazy that it keeps going every single day. Crazy. But yeah. We're gonna, take a look at some problems today. So, I think we're gonna finish off. We're gonna finish off our final roadmap problem here, which is reverse integer for bit manipulation. I'm happy that I went through this again. Extremely happy. I have not solved this one before. I attempted it. November 16, 2023, compile error. Fair enough. Okay. It's got a 30% acceptance rate. But anyway, let's take a look. Given a 32-bit integer x, return x with its digits reversed. Reversing x causes. Let's actually pull up our Scally draw. We'll grab our. So we're just reversing the digits pretty much. I mean, we'll read the description, but fundamentally, Goku, how are you, bro? I am good, dude. I am good. How are you, bro? Given a 32-bit, 2-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the 32-bit integer range, then return 0. Assume the environment does not allow you to store 64-bit digits signed or unsigned. Interesting. So let's think about it. I guess we can kind of copy what we wrote here. So if we were to do 123, right? 123, and we convert that to binary. Good too. That's good, bro. What have you been up to today, dude? Let's write this in binary. Shit, dude. Do I want to calculate this in binary? Probably not. Let's just figure out what it is in binary. 123 in binary. I don't really want to do it myself. Is this calculated, dude? Oh man, they're making me do it myself, dude. I don't want to do it myself. Binary. Oh, decimal to binary. 123. There we go. Sweet. Thank you. Thank you for that. Okay, so we're working with this number in binary, right? So how would we want to reverse this? I guess maybe we could work with probably a smaller number. To think about it, 10110 or 1010. What is 11? I think 11's a good number. 11201. 3, 4, 8. So this is 11, right? Nothing much. Still learning JS. Nice, dude. You working on? I'm sure I've asked you this before, but you working on any projects yet, or are you just kind of learning vanilla JS? And how are you learning it too, bro? Is it on YouTube, or is it like you bought a course or through school? Or sorry if I've asked you this before. I'm just curious. Okay, so 1011. How can we reverse this? What is the best way? Let me pull out my notes here, dude. See what we looked at the other day. Man, cannot grab my notes, dude. Here we go. Grab my notes here. Hmm. So you grab the last bit, and then we bit shift, right? Maybe we can do. So we're given a 32-bit signed integer. Oh shit! So we're gonna get negative values too, bruh. Ah, dude, I feel like when we're working with negative values, it's gonna be completely different. But okay. Anyway, I is less than 32. I plus plus. We did plus plus I. All right. Oh shit! We did plus I. Whoops. I am not in the phase of making some real projects yet, trying to understand things every day, and if I forgot something, I relearn it by watching tutorials on YouTube. So, or I also have Udemy course. Nice, dude. I don't know if I mentioned this to you while you were watching me on stream, but I did this Udemy course. This one. I've said it on stream before, but I really recommend this course. Dude. It was really good. Like, I don't know if you've, I don't know, maybe this could be the one that you're doing, that you're looking at. I have no idea, but I thought this was extremely good. It didn't go like super in depth, you know, like really, really in depth. It has what, 60 hours of content or something. Yeah, 61 hours of on-demand video. Oh shit, you did this one too? There you go, bro. Yeah, I did this whole course, dude. Took me a few months to do it. It doesn't go super in depth, but like it was enough like surface level content to like get comfortable, you know, with web development. Now I'm pretty comfortable with it. I mean, I don't know everything about React. Like when I'm using React, like I'm learning from the same course. Okay, there you go. Nice. Yeah. Yeah, it doesn't go super in depth, but it's, you know, it was good. Like it gave me a surface level like of, you know, hooks, like, you know, I use state hook and use effect and, you know, all the other ones, but you know, I still gotta look up shit like all the time when I'm doing it, like how to use, like I've learned how to use a use state, but like, you know, sometimes I just gotta relook at it all the time. So it's, but I like understand the fundamentals, which I think is the most important thing. I built a few projects, so that was good. Until Bootstrap, everything was cool. Now I'm on JS, it makes my brain fart. Yeah, yeah. I thought the best section, dude, the best section of this course is, so you're up to probably here, like the JavaScript section here. I would say the best part of this course was when I got to here. She's a super cool teacher. Yeah, she's great, dude. Getting to like the APIs, dude. And then doing this capstone project was good. Doing the databases and then learning React, like, and the authentication was really good too. This section was really good as well. So probably this section here is like the best part of the course, I would say. Yeah, the DOM, yeah. Document object model, DOM. Let's go, dude. Yeah. Course is really good, dude. Highly recommend it. But yeah, this is the best part here. When you get to the APIs, you're doing authentication and like all that sort of shit. Like, you learn a shit ton. Like, but I stopped. I didn't finish the whole course. I stopped after React. So I didn't do the Web3 like this bullshit at the end here. I just didn't think I was really interested in that. I just kind of wanted to get to the React part and get that foundation. So, and now I'm pretty confident like with React and you know, like, yeah, backend development using, you know, whatever. I've been working with Firebase a lot recently. I love Firebase, dude. It's so easy to use, but it's really good. But yeah, so definitely would recommend the course, dude. It was really good. I'm really excited to learn React, but for that, I think your fundamentals should be strong. Yeah, Yeah, I think so. I mean, if you've programmed in other languages before, I feel like it's pretty straightforward. But the you know, learning the specific JavaScript stuff, like you know, what is that, like filtering, shit, what is the other one, mapping, and you know, the promises, and you know, shit like that. What date is it today? Here in India, it's 4 a.m. in the morning. Where are you from? I'm also learning JS. I'm from Australia, but I live in the United States, so it's like 5:40 here. But yeah, learning all the JavaScript stuff, like promises, and you know, the await keyword, and you know, all sorts of fucking asynchronous functions and that sort of shit. Like, it's not too bad, bro. I wouldn't focus too much on the JavaScript, dude, because like, you know, just try and get those fundamentals, and then, you know, keep moving through the course. Like, you know, I feel like you know, you spend too long, like, you'll never make it to the end. So just keep pushing through. Well, that's cool. You're doing the same course, bro. I love this course, dude. I'd recommend it to anyone. It's just tough to get through, dude. I've recommended it to a few friends, dude. They never finish it. Like, but if you finish it, dude, and you get to the React part, and you finish React, like, it's good. Yeah, learn about everything here. Use state, event handling, yeah, dude. I still cannot believe I finished it too, dude. It's crazy. But it took me a few months, dude. I think I started it in like February and finished in like June, maybe. But yeah, anyway, let's get back to this problem. Integer x return x with its digits reversed. If reversing x causes the value to go to. Damn, bro. Trying to think here. 1011. Cool, bro. Yeah, dude. It's cool. Are you a student, Goku? I can't remember. You a student, or are you like a university student or whatever? I'm trying to think here. So let's take a look at what we did yesterday, just to refresh what we did yesterday. We're doing a lot of ZORs and doubt. How does one remember syntax even though we have IDEs, and also during interviews we ask the code on online compiler, so remembering syntax becomes important, right? Yeah. Probably, I would say. It is tough with the syntax, dude, especially when you work with different stuff, but I guess just try your best, dude. I don't know. If it's meant to be, bro, it's meant to be. Taking out carry here. A XOR B adds them together. Dude, I don't have the intuition for this problem. See, there's discussions, looks like. Damn, bruh. Dude, maybe I should watch a video, dude. I don't know. My initial thought, right? I mean, when we were reversing bits the other time, what were we doing, right? We would... Yeah, I'm a university student from Pakistan. I just finished my first semester. Nice, dude. That's good that you're getting on it early, though, bro. That's good stuff, dude. Doing that course will definitely help you a lot. Right, we take this one, right? How do we take this one? Well, we can do... take our number, our current number, like 123%2, right? Can tell if it's 1 or 0, right? We take that last number, and then we what? We probably want to left shift, right? Left shift our result by 1. Hang on. Let's see here. What? So we in result and %2 we left shift result plus or equal to last bit. Then we right shift by 1. Take the least significant bit appended to the result that you're building from left to right. Jake Jones, low key, dude, low key, bro. What's up, dude? Put it to a result that you're building from left to right. Make space in result. Man, these problems are so tough, dude. So tough to think about. Like, can you explain how this one zero one one and n1 is equal to 1? Ah, dude, this is so tough, dude. So tough to think about. Let's look at reverse bits, actually. I mean, we looked at that the other day. Reverse bits. I need to relook at this again. Fuck, dude, where's my pen? Let's look at how we reverse these, right? So we're given a number, right? Let's see, we're given 1011, right? Okay, to reverse this, this here takes our last, I can't even type here. So we take our last digit, right? So we would do 11% 2, right? So we get our last digit is 1, right? Then we do result left shift by 1. We left shift this by 1, we get 10110, right? Result plus or equal to last bit. So I believe when we add this, I think it does this. Or am I wrong? Llama, dude, what's up, bro? Good to see you again, man. Let's take this. Iteration for 1011. Let's go step by step. Right, we get our last bit. We bit shift left. Last bit. Result, we bit shift left. My gosh, dude, this is throwing me off. How's your day been, Llama, dude? Result is equal to 0, bit shift 1. Oh, our result is 0. Okay. Yeah, okay. I'm tripping, dude. Okay. So, not like this, right? That's why I'm so confused here, right? We grab 1, right? We grab our last digit. We bit shift left on that result. Sucks, no AC in the office. Oh, shit, dude. That sucks, man. I'm sorry, bro. But happy to be here, man. Appreciate it, dude. Happy you're here too, dude. Thanks for stopping by again. Stopping by every day. Appreciate it. It's getting to kind of a grind, dude. Being at like 78 today, dude. How many days we've done? What is this guy saying? Sudha says, let's say you got a number as an input and it's 4, 5, 6, 8. And then use a variable that is reversed as equal to 0 and use a loop to extract the digits from last to first. Yeah, I'm trying to... You will make more than me. I'm not sure about that, Llama, dude. You're the GOAT, bro. Using %10. Sudha, thank you for the comments, bro, but I'm trying to do it in a bit manipulation way. I don't think that's bit manipulation. But I know what you're trying to say, like to reverse the digits using a for loop. I know. I agree with you. Very smart and diligent, bro. Thank you, Llama, dude. I really appreciate it. I do not consider myself smart at all. I actually really struggle with my self-confidence all the time. So I do appreciate your kind words, though. So thank you. Anyway, we continue, right? We grab our last number here, right? So our last number being 1 here. We grab our result, we bit shift left. Our result is currently 0, right? So when we bit shift left of this, right? I mean, it's just going to be 0, right? So our result technically is just going to stay at 0, right? And then we do our result plus or equal to last bit. So we add our last bit here, right? So 0 plus 1 is 1. That's what smart people say, XD. Yeah, I don't know, dude. I don't know, man. It's definitely tough, dude. I do struggle a lot, but I just try and... Black Arch, hey, what's up, dude? I just try and stay consistent with my stuff, dude, and what I like to do. So thank you, Llama. I do appreciate your kind words. Thank you. Anyway, in our second iteration here, we grab our last bit again, right? So the last bit of... Oh, sorry, shit, we forgot to bit shift right here. Whoops. We bit shift right here, right? We have our N, which is currently this. We bit shift right. Hook me up when you make mills, dude. Thank you, bro. Keep on with it. Thank you, Sudha. Black Arch says Leetcodin crying. Yes, sir. The Leetcodin. I am doing some Leetcodin. Alright, bro. I'm gonna go sleep. Have a good day and take care. Thank you, Goku. See you later, bro. Appreciate you coming to hang out, dude. Get our result here. 0 plus 1 is equal to 1. So we bit shift right here. If we bit shift right, we get... Can feel your brother. Yes, sir, dude. It's definitely AIDS, dude. 1, 4. So this would be 5, right? We bit shift right, we get 5, right? Just trying to get these fundamentals here, right? Our second iteration here, we get our last bit here. So our last bit is 1 again, right? We... Then bit shift left with our result, right? So our result now is 1, right? Here. Just saw the stream, what you're doing. I'm re-looking at this problem we looked at yesterday. Because I'm doing the different problem, reverse integer. I just kind of want to get that, remember how I did it yesterday. So grabbed our last digit, right? Then we... our last digit is 1 again because we're looking at 5, right? Then we do result is equal to bit shift left of 1. So shit, dude, I'm confusing myself here, dude. We got 0, we got 1 here, right? So we bit shift left, we get 1 0, which is 2. Yeah. And then we do our result plus or equal to our last bit. So then we add our result, we get 3. So our result is now 3 in this iteration. Doing these questions makes one feels dumb and questions one's intelligence. Happens with everyone. Yeah, dude. It's definitely, it's tough doing it. I was doing these problems back in the day, bro. I did exactly what you did, Sudakar. I just, you know, used a for loop and reversed it. But, you know, I'm trying to like really learn the fundamentals of bit manipulation because I really struggle with these sort of problems. So I thought I'd begin by doing Leetcodin's like roadmap for the bit manipulation problems to get the foundations, because I want to become a bit manipulation pro, dude. Sounds so weird to say, but I just feel like these are the problems I struggle with the most, or I have the least fundamentals on. So anyway, so our result is 3. Then we bit shift n by 1, right? So currently at 5, we bit shift right. I believe we would get 0 1 0. So then we bit shift right. Now we're at 2. Right? Our result. Yes. Okay, so in our third iteration here, right, our third iteration, we get a 0, right? Because we're looking at a zero result is equal to 3 0 1 0. We're looking at result as 2 here, right? Our result is currently 2. Well, sorry, our n is 2, my bad. Our n is 2 here. We're grabbing the last digit. So our last digit here is 0, right? So then we do result. We left shift our result, right? Our result is 3 right now, right? So our result is currently 3, which is 1 1 0. Sorry, no, it's 0 1 1, right? We bit shift left by 1. So we would get 0 1 1 0. Right, which would give us then 2 6, right? We'd be at 6, which is correct. Then we add our result, right? We add our last bit, so 6 plus 0 is 6 again, right? And then we bit shift right, dude. And when we bit shift right, we're at 2, then we're gonna get 1. So we go 0 0 0 1, right? We come to our fourth iteration here, and mind you, this is gonna loop 32 times, right? So our fourth iteration here is okay, so fourth iteration, right? So we're looking at n%2. Our n is 1, so we're gonna get 1 here, right? That is correct. Yep. We have our result here. We bit shift left. So when we bit shift left, our result is currently 6, and we bit shift left. So 0 1 1 0 0, I believe. Which is what? 1 2 4 8 12, right? We then add our last bit, which then would be 0 1 1 0 1, which is 13. And then we bit shift n by 1. So then our n would go to 0, right? We bit shift 1 by 0, it would go to 0. And then every other iteration will obviously return 0 every single time, right? Because we're grabbing the last digit being n, so our result will never change, right? So our final return here will be 13, I believe that is correct. What did we start with? We started with... How old are you? Just a random question. I'm 24, dude. I just turned 24. 1011. What did we start with, dude? This is... Did we reverse this properly? One one zero one. Yeah, right. This is our reverse here. 1101. This is our final answer. So is this correct? We started with 1011. Oh, that is correct. Okay, so we did reverse it, right? So that worked. So now we come back to our problem here, and we have to think about reversing this. How can we think about doing this? I feel like from all we've learned, let's look up. Oh, shit. You know, I'm not sure. I feel like we would still loop 32 times. How can we res? Definitely need a res in and what is like 32T or something? What is it in C++, dude? uint32_t. uint32_t is equal to currently 0, right? Got to name it. Name it a res. We loop, right? So what would anding yeah, dude, I'm not sure. I'm trying to think about everything that I learned. Zoring adds, right? Without the carry. We simulated the carry with how did we simulate the carry yesterday? Sum of two integers. We simulated a carry with A and B left shift by 1. Damn, dude. Damn, bro. These problems are tough, dude. They got no hints, dude. No nothing, dude. This is tough, dude. Should be marked as an easy problem. It's pretty simple. One, in my opinion, no need to brainstorm. DS or Helga. Thanks, Name Moller. Giving us all hope. Let's look at this guy's count, dude. Oh yeah, this guy's cracked, bro. Look at this guy. Bro, every day, dude. Oh my gosh, dude. That is insane. Wow. This guy just never stops, bro. Wow. That's impressive, dude. Give it to this guy. This guy's cracked. Passionate programmer, dude. Let's check out his GitHub, dude. Yeah, bro, this guy's cracked. Interesting, dude. Fair enough, bro. Okay. Anyway, what are you making? I am not making anything right now. I am working on a reverse integer and thinking about it in terms of bit manipulation. If you're talking about what projects I'm working on a C++ game, and I'm working on a just a little passion project called Rate My Frat. What is bit manipulation and what is it used for? I only know we use dash sign for it. Yeah, dash sign. That's left shift. Bit manipulation are just problems where you're working in bits, you're reversing integers, working with bits. I don't know. They're bit problems, dude. I don't even know. Do you know how to code Lua? I have never worked with Lua in my life, but I'm sure I could pick it up if I wanted to learn it. So, reverse integer, dude. Okay. Guys, I think what I'm gonna do is I'm gonna watch a video. I feel like that's the only way you can learn sometimes from someone else. So I think we're taking the L here.
Welcome back, and let's write some more neat code today. So today let's solve the problem reverse integer. Even though this is marked as an easy question, I would say that this is definitely more of a medium question, and that's probably why this question has so many different so many dislikes. But I don't think it's actually a bad problem. It's definitely good when it comes to bit manipulation. So we're given a signed 32-bit integer x. The fact that it's 32-bit is very important here. We want to return this integer x with all of its digits being reversed. And the only catch here is if reversing this integer x causes the value to go outside of the 32-bit integer range, which is this.
Napo Bro says, hey, just a question. Did you do computer science in uni? I did, man. I did study computer science, but then we basically want to return 0 if that's the case, because we're working with 32-bit integers. If the integer overflows, then we want to return 0. And this is the portion that's actually going to make the problem difficult, because we are working with 32-bit integers, and we cannot assume that we can store 64-bit integers or anything greater than 32 bits. That's what makes this question difficult, I think. Because if we just take a look at the standard procedure that we use 0 if that's the case, because we're working with 32-bit integers, if the integer overflows, then we want to return 0. And this is the portion that's actually going to make the problem difficult, because we are working with 32-bit integers, and we cannot assume that we can store 64-bit integers or anything greater than 32 bits. That's what makes this question difficult, I think. Because if we just take a look at the standard procedure that we would do, take the first example over here. We have 1, 2, 3. Did you know we can chop off this ones place digit pretty easily? You can do that by modding this by 10. If we mod by 10, we're basically dividing this by 10, except we're getting the remainder, which is exactly what we want. That's how you get the ones place. If I took 123, divided it by 10, what would be the remainder? It would be 3, of course, right? So then we can get 3. So with this digit, we want to create a new integer, right? So we're going to start our new integer just being 3, right? This is the result that we're returning. It's going to be 3. Let me, write it down over here, 3, right? Then another operation we can do on 123. Now that we've processed this ones place, we don't really care about the ones place anymore, right? We don't care about this 3. Now we want to look at the next digit, right? So how can we basically chop this digit off? Well, it's pretty easy. You basically take 123, divide it by 10. When I say divide, we're not doing decimal division, we're doing integer division. So when you do integer division, we round towards zeros. If we divide this by 10, we will get 12, because we're rounding down, we're rounding towards 0. So now we have 12. We're going to basically repeat that exact same step that we just did over here. Basically, now we're going to take 12, mod it by 10, and now we're going to get the ones place, which is 2, right? That's the digit we were looking for. So now we want to take this 2 and add it over here, right? Now, how can we do that? Well, we have a digit, we have a value 3. So let's take 3, multiply it by 10. What do we get? We get 30, right? Why did we multiply it by 10? Because we wanted to shift this 3 to the left by 1, because now we're going to take this 30, add 2 to it. Why are we adding 2? Because that's the digit that we just computed up above, right? So we add 2 to 30. Now we get 32,
right? So we're almost done reversing this integer, right? If you take a look over here, we started with 123. We reversed the first 2 digits, right? But now we want to reverse the last one, which is 1, and that'll be pretty easy. We'll just continue the steps that we've just done up above. So then at the end, we'll have 321, and then we'll return that, which is exactly what we wanted to do. And believe it or not, we can do this exact same procedure on negative numbers, and it works out the exact same. So that's the good thing. The only downside is we haven't covered what are we going to do if the digits overflow. So let me kind of explain that to you, this range that we have to kind of meet. So in the description, they say that if the value goes out of bounds, so take a look at the left, they say if it goes out of bounds from this range, then return 0. Now, what is the value? -2, or 2 to the power of 31 negative, right? -2 to the power of 31. What is that value? Well, you can see over here, this is that full value. These are the digits. What is 2 to the power of 31 minus 1? This is that value. So what if we had a example that looked basically was too large, right? What if the value was too large to fit? What if the value was actually larger than the max value that we can possibly have? What if the value was 2147?
Here's how to use Browse AI. Enter the URL you'd like to scrape, and then start training your robot to work for you.
Damn, Pseudo
What if the value was the exact same as this, except plus 1? You can see that this is the exact same value, except I added 1, so this is an 8 instead of a 7. And actually, what if the input value was this? Basically, what if the input value was the reverse of the max digit plus 1, right? Let's say this was our input value, right? And let's say we reversed it. If we reversed it, this is the reversed value up above, right? This is what we would get. But what we know is this integer is actually too large. This integer is greater than the one up above. So this would not even fit into memory, so we would need to return 0. Now, how could we detect that this integer overflows without actually calculating it, right? Because we can't have this digit. This digit is impossible to have in 32 bits. So how would we detect it without actually building this number, without actually taking this and reversing it all the way to here? Well, that's the trick that I'm going to show you. We actually are going to reverse this input digit by digit, except for the last digit. We're not going to add the last digit yet. What we're going to do is once we've reversed this, right, we have all but the last digit. We're going to check, okay, is this value exactly equal to this value? Basically everything from the max digit except the last digit. How are we going to actually get this? Basically, we can take the max digit and divide it by 10, right? Because dividing by 10 will take the ones place digit and chop it off, right? So if we do that like this, we're going to check, okay, is our reversed integer equal to this one? Yes, it is, right? It's exactly equal in this case. Okay, and then the next question we're going to ask ourselves is, okay, we're trying to...
Okay, this seems really confusing what this guy's saying. At least to me it does. Okay, so I was wrong here. So in res, I feel like we probably have a while loop here, right? So while x is greater than 0, we can take our last digit, right? To grab that, we can go what? Shit. Hex %10, right? And then what did he talk about doing after that? Grab the digit. Right, and then what do? We divide by 10 or something, right? Divide by 10. There we go. X divided by 10. Then we have to figure out how bounds. You're doing unsigned first. No, I'm trying to. to be honest, I don't really know what I'm doing. Am I doing unsigned first? I'm just literally just wanted to write the code about grabbing our last digit, right? So grabbing 3 from here and then dividing it by 10, right? We grab this digit, divide it by 10, right? Which will give us 12. Because while it won't work if it is negative num. Ooh, yeah, that's true. This is painful for them. It's easy. For us, it's not. Yes, bro, that is true. Yeah, you are right, Llama. You are right. Sorry, I didn't think about that. Maybe while the not equals 0. Because won't that work for both? Or no? I think that'll work for both, right? If we go all the way to 0, we keep dividing by 10. All Gucci, bro. Yeah. Honestly, dude, when he's explaining this part here, dude, this shit is AIDS, dude. Shit is AIDS. I think I'm gonna have to step through this painful watch here, dude. Like, because this is tough what he's talking about here.
Right, negative 2 to the power 31. What is that value? Well, you can see over here, this is that full value. These are the digits. What is 2 to the power of 31 minus 1? This is that value. So what if we had a example that looked basically was too large, right? What if the value was too large to fit? What if the value was actually larger than the max value that we can possibly have? What if the value was 2147? What if the value was the exact same as this except plus 1? You can see that this is the exact same value except I added 1, so this is an 8 instead of a 7. And actually, what if the input value was this? Basically, what if the input value was the reverse of the max digit plus 1, right? Let's say this was our input value, right? And let's say we reversed it. If we reversed it, this is the reversed value up above, right? This is what we would get. But what we know is this integer is actually too large. This integer is greater than the one up above. So this would not even fit into memory, so we would need to return 0. Now, how could we detect that this integer overflows without actually calculating it, right? Because we can't have this digit. This digit is impossible to have in 32 bits. So how would we detect it without actually building this number, without actually taking this and reversing it all the way to here? Well, that's the trick that I'm going to show you. We actually are going to reverse this input digit by digit, except for the last digit. We're not going to add the last digit yet. What we're going to do is once we've reversed this, right, we have all but the last digit. We're going to check, okay, is this value exactly equal to this value? Basically everything from the max digit except the last digit. How are we going to actually get this? Basically, we can take the max digit and divide it by 10, right? Because dividing by 10 will take the ones place digit and chop it off, right? So if we do that like this, we're going to check, okay, is our reversed integer equal to this one? Yes, it is, right? It's exactly equal in this case. Okay, and then the next question we're going to ask ourselves is, okay, we're now trying to add another digit. We add the ones place digit. Okay, so how do we know then if the resulting integer is going to be greater than this max integer up above? How do we know that? Well, all we have to do, since we know that this is equal to this, now all we have to do is compare the ones place. Is 8 greater than this integer we have over here, which is 7? In this case, it is greater than it, right? So then we're not actually going to take this 8 digit and add it to here, add it to this entire integer. We're actually going to return 0 immediately. So that's one trick that we're going to basically to detect if we go out of bounds. And so basically, I just showed you the example of what we would do for positive integers. The exact same is basically going to be true for negative integers, except instead of checking if this digit is greater than the ones place of the max negative integer or the minimum negative integer, we're not going to check if it's greater. We're going to check if it's less than, because this is a negative number, right? So that's one way we could detect if we did go out of bounds. Another way we can actually check is taking away this final digit, right, this ones place digit, and taking away this ones place digit again, and we do know how to do that in the code, so I won't explain it. But And we were comparing all of these digits, right? And we were comparing all of these digits, and let's say we knew that, yes, we are about to add another digit. We know for sure we're going to add another digit. Then what we're going to ask is this portion down here that I have squared up, is this greater than this over here, right? For example, over here we have a value.
Don't overpay for car insurance just because you're under 25. With Lemonade,
we have a value 2 followed by 8 different digits, right? So suppose this value over here that I have written over here, it wasn't 2 followed by 8 digits. It was a 3, 0, 0, 0, 0, 0, followed by 8 zeros, right? Then we know for sure this is actually larger than this integer I have up above. Since we know this is larger, and let's say we're adding another 0 to it, so now we have 9 zeros, then we know for sure it's going to be greater than the max integer up above, because that max integer starts with a 2 followed by 9 digits, right? We know for sure this is going to be greater, so basically that's how we're going to compare it. I know this sounds confusing, right? But to put it simply, if we compare this with this up above, and we know that this is greater, then we know a digit. We want to
code here. So if our res is greater than max, divide by 10. Sorry, what is this in Python? I don't remember. This is divide, right? Ethan, dude, what's up, bro? Sorry, my buddies are texting me, guys. My bad. Bro, are you taking a gap year? No, I am not taking a gap year. Is that remainder? No, I think it's divide. I just looked it up. Sorry, my buddies text me on my phone, dude. I understand the explanation is easy, but how are you going to write the code for it? It doesn't just sound confusing. It is confusing. Hello, can I join too? Lijan. Yes, sir, dude. I mean, we can do some problems together. I mean, you can join the Discord. Jeez, sorry guys, my bad. My minus floor divide, my bad. Yeah, hang on. Sorry guys. Okay, so if our res is greater than the max divide by 10, or res is equal to max divide by 10 and digit is greater than max percent 10, return 0. Can I get your Discord? It's in the description, dude. Discord's in the description. So yeah, this is in Python. Yeah, res times 10 plus digit, right? So yeah, that makes sense. That makes sense, right? We times 10 to get our digit, right? So come over here and we do what, like res res is equal to res times 10 plus digit here. Right, and here's where we have to figure out our bounds. I don't really fully understand these bounds, to be honest, dude. I can kind of read what it's doing, but I'm not really like 100% familiar with what is going on. Res is greater than max. Let's search up what max is in Python. I don't even know, dude. I think it must be just a 32-bit max integer, I would assume. Does he define? Oh, he defines it here. Oh shit. Whoops. Jeez, I'm stupid. Okay. Res is greater than max. Divide by 10. Which I think. Or res is equal to max. Divide by 10. And digit is greater than or equal to max percent 10. So we're checking our last digit here. Right? We return 0. Alright, if res is less than min, divide by 10, or res is equal to min divide by 10, and digit does not equal min percent 10. Res times 10 plus digit. I guess we should probably put this in brackets. Figure out our bounds here. I think in C++ you can int max, right? In C++ represents the maximum value that an int data type can hold. Wow, dude, look at me, dude, learning C++, dude. I don't know how I remembered that, but so what we go here and we do if res is greater than int max, right? I think that's what it is, right? I don't know. Divide by 10, right? Or res is equal to max divide by, oh sorry, int max divide by 10. And then we're checking our last digit here, right? So we take, and as you said, you did a Udemy course on web development. Why don't you continue making projects there, or are you doing DSA and dev both together? I do both. I've worked on, honestly, you need to use SED numeric limits max instead. Okay, let me look at that. It's better practice here. Okay. To answer your question, Sudha, I do both. I work on some web development projects. I'm working on a C++ game right now. Done heaps of web development projects. I'm working on another one right now, just in my free time. But yeah, I work on both. So appreciate the question, dude. Let me look this up. STD numeric limits int. Template custom has a way to query. Supposed to specialization numeric limits class template. So are you saying, Ethan, instead of using int max here, returns the maximum representative finite value for int? Is web development any fun? I know it's useful to know, but it seems a tad boring. Yeah, it's alright, dude. It is fun. Did the web development course. But yeah, it's alright, dude. It's alright. So we got res is greater than what we have, right? Res is what has he got here? Shit. I guess we can just follow this. Or res is equal to max here, divide by 10. These bounds are tough, dude. And digit. All right, we're calculating our digit here, and digit is greater than or equal to I guess, shit, instead of calling this so many times, dude, what am I doing, bro? I can just do, like, max is equal to this, min is equal to... what is your usual time to come live? Usually around this time, dude. Usually in the evenings. Hang on, I have to figure out what is the min one. Here it is, the min one. There we go. So now we can replace this bullshit with max. Get rid of this crap with max. Get rid of this crap with max. Hey, maybe you need to think in terms of remainder here because you want to make sure the n value doesn't exceed that range in Ka, only go up to 2.1 lb including neg and pos. Okay. And digit is... Digit is great. If result is greater than SCG numeric int max, result is less than SCG numeric int min. You also don't want your if statement in the while loop. Oh shit. Yeah, you are right. So you're saying I check this outside. Okay. If result is greater than... Mose Mareben. Hi, dude. What's up, dude? How you doing? You need to make the result type 64 bits wide. What int? What is it? U? I think it's like what? U int underscore 64? U int 64? Fuck, dude. How do you do it? U int 64. That way you can handle the... You're right, Ethan. Yeah, that is true. What is it? Turn it to string, reverse it, and turn... Thank you. Thank you, Mose, dude. Appreciate that. uint 64 C++ uint 64 underscore T. Fuck, I fucked it up. uint 64 underscore T. Yep. Thank you, Ethan. So you're saying if results is greater than max, if result is greater than max or result is less than min, I guess we can just return 0. Otherwise, we return our res. Yeah, let's see what that gives us. You actually don't want uint here because you need to handle negative numbers in 64 underscore T. Okay. What is the difference between in 64 underscore T and uint? I actually have no idea. I'm gonna look that up right now. Difference between uint and int 64. For an int 64 uint means the size of the integer is 64 bits, but the range is different. There are two kinds of 64-bit integers, signed and unsigned. int 64 is the signed type, uint is the unsigned type. Ah, okay, right. Makes sense, makes sense. Undeclared identifier. Oh, whoops. Res. Error use of undeclared identified digit. I misspell it. That's an L. Compiler use of identified result. Oh, that's be res. Whoops. Are you guys coding in CPP or Python? CPP, bro. There we go. Sweet. Shit, man, that problem was AIDS. I think we spent like over an hour on that, dude. Yeah, like an hour on that. Oh, man. But yeah, I'm gonna call it there. Anyway, before we call it, Napo Bro says, do you think it's worthy a SWE major? Because I'm afraid AI will take it in the future. Look, man, if you love to program and you love to code and you love computer science, just do it, bro. Like, it's what you love, man. Good job, Max. Thank you, Ethan. Much love, dude. N64T. It's a signed integer, Aryan. What Ethan just said. All 64 bits. There you go. Appreciate the love, dude. See you guys later. I'm gonna end it there. I'm gonna go work on my project. Damn, it took me 3 hours till I had to see edit tutorial. Yeah. And the 64-bit represents a sign. Yeah. Yeah. So thank you guys. Appreciate it. See you tomorrow. For day 179. I'm gonna go work on my project now. So see you guys later. Peace.